So thank you for joining my session, which is Hop on the Serverless Adventure. So I know that today's or this morning's keynote has covered serverless as well. So I'm kind of assuming that you do have a short intro or some knowledge about serverless, but I'm also going to do a shorter intro so that we are all on the same page. My name is Simona Cotin, and I work as a cloud developer advocate for Microsoft. And my role there is basically to make sure that we are creating a great developer experience, and especially for JavaScript developers and web developers. And at least that's why I'm there. I have other colleagues that work on Golang or Java or .NET, and their job is to make sure that their community is feeling great on Azure as well. And this little mascot that you see here, their name is Bit, and it has been built by our colleague Ashley McNamara. I recommend you go check it out. We have amazing artwork from Ashley, and you can reuse it whenever you want. Okay, so cool, serverless. Everyone here is here because they want to learn more about serverless, right? Who here has looked into serverless before? Perfect, awesome. We have maybe half of the room. I'm going to start with a very short definition, where basically we're just putting serverless in two different categories. So the first part concerning serverless refers to applications that depend highly on third-party services. And by third-party services, I mean services like Auth0 or the Zoopla API, or maybe a database. So that means that most of your application is using third-party services. But then when you're building an application, obviously you have some custom logic as well, right? So you need to implement some custom code. And that's the second part of serverless, which is functions. And that's like function as a service, and is the custom code that will help you build the logic of your application and bring value to your business. This is an amazing animation that our colleague Sarah Dresner has built. And she is basically just showing the evolution from infrastructure as a service to function as a service. So back in the day when we started, we used to buy our own hardware, but then maybe cloud provider, or not only cloud providers, they decided that there's actually a business in making sure that people have the hardware that's required for their business. So instead of buying your own servers and replacing them when there's a faulty hard disk or something, you just go to someone that rents their hardware and make sure that they're replacing whatever needs to be replaced. And that's infrastructure as a service. But then we took it one step further, and we're like, hey, managing operating systems is actually very easy to automate. And applying patches, like security patches and updates, that's something that someone else could take care of. I don't necessarily have to hire people for that. And then that's when we got to platform as a service, where you're basically deploying maybe a Node.js application on an operating system like Windows or Linux. And the cloud provider is making sure that your operating system is up to date. And finally, we got to the tip of the iceberg, where we no longer have to care about servers, we don't have to care about managing them. All we want to do is write code, deploy that to the cloud, and don't care about anything else. Perfect. So then another thing that you might have learned this morning is that when we're writing custom code, so function as a service, we are writing code that reacts to events. And what I mean by events is things like whenever someone has uploaded a file on a storage account. So say, for example, a new CSV has been uploaded, and that triggers an event which runs some code for us, for example, processing that CSV file, and then saving the data from that CSV file into the database. So that's one example of an event. Another type of event that we can react to when writing serverless code is HTTP triggers. So that means that if someone makes an HTTP request, we can execute code in a response to that event. Another cool characteristics of serverless is auto-scaling. Who here thinks scaling is an easy problem? Yeah, right, 0 hands up. So it's quite nice to be able to outsource some of that problem, right? So with serverless, we are outsourcing auto-scaling to our cloud provider. And this means that if our with serverless, if we have 10 users for our application or 10 users for our code, if by any chance we get very successful overnight and we get 1 million, 1 trillion users getting to our application, serverless will help us deal with that kind of amount of people. And finally, pay as you go. With serverless, you only pay for the CPU time that your code uses and the memory that your code uses. And this is opposite to paying almost like a monthly rent, right? Because when we're using a platform as a service, we're not paying based on the resources, only on the resources that we're using, but we're paying a monthly fee for the resources that we're using. With serverless, is pay as you go. Okay. So if you're curious about how much you would have to pay with your serverless code, you can go ahead and check that at serverlesscalc.com. And then you could configure there like how many executions you'll have for your code, how much memory you're using, and maybe include things like a free tier, because most of the serverless providers will have a free tier, maybe something like 2 million executions or something like that. So serverless calc is very useful to figure out how much money you might end up paying on a monthly basis for your code. But eventually, what's really great with serverless as well is the fact that we actually get to release our code very fast and with a much smaller team. So many times when I speak with people about serverless, the phrase I hear most often is, you know what, I have to spin up very fast, like in 2 months' time, I have to spin up this new solution, and I think serverless is the way to go, because it helps you kind of prototype your idea, but also deliver as fast as you can with very few people. There are, though, some things that you need to consider. Functions normally have a time limit. So depending on the cloud provider, you will have a limit to maybe 5 minutes or 10 minutes on the execution time. So this means that your functions need to be very small. And in a way, that's nice, right? Because you won't have to, you're separating your logic in smaller pieces that are much easier to maintain. Another maybe good thing or bad thing with functions is that they're stateless. So that means that in between runs of functions, you cannot rely on having state stored neither on the disk or in memory. If you want to pass state from one function to another, you might choose to do things like store a message on a queue, or maybe store something in a database, but you cannot just do the traditional way where you're saving state somewhere in somewhere on an object, and then expect the next run to have access to that data. The fact that functions are stateless actually give us this power where we can auto-scale immensely, right? And this is an advantage as well. Finally, cold start. Who here has heard about cold start in terms of functions? Okay, cool, just a few hands. So cold start refers to the time it takes for a function or for our code to be deployed up into the cloud inside a container or a virtual machine. So because our code is stored somewhere in a storage account, and then basically whenever a request comes in, what happens is the cloud provider or the solution, it will just take that code, deploy it on an operating system or in a container, virtual machine, whatever, we don't care, in a web server, but it takes time, right? And then you also, maybe you have dependencies. So if you're doing Node.js, you will definitely depend on some Node npm packages, and those have to be installed. So cold start is the time it takes for our code to be deployed and up and running in the cloud and have everything installed. And this means that if you're doing things that are like really require low latency, then definitely serverless is not necessarily the best solution. But with things that are not on the hot path of your application, you can definitely use serverless. So in summary, what serverless computing helps us with is definitely the deployment of our application, because we are outsourcing a lot of the hard problems or the automation problem or the simple task that can be automated to someone else. And some of the tasks that are actually quite a good fit for serverless are things like image processing. We have to do that a lot, right? And it's not necessarily something that has to be done in like 100 milliseconds, so we can maybe send that to a function. Task management, workflows, and notifications. How many times do we have to send emails? Imagine handling that separate from any other part of your application in a simple function that will do that automatically for you. Why Node.js? How many of you here are Node.js developers? Awesome, maybe half of the room. Because it's awesome. But also, because JavaScript already has a huge amount of libraries that have been implemented for us, and we can take advantage of all of them. NPM, I think it has gazillion packages. We can reuse all of those in our serverless environment, so we don't have to reinvent the wheel. Also, by using JavaScript, we are enabling JavaScript developers to basically not only write auto-scalable front ends, but also back ends. And that's cool. One of my friends who's actually running serverless days, and he was running JeffConf, he was saying that he was at JeffConf Milano, and he asked in the room like who was a front-end developer at that conference, and I think 90% of the people in the room were front-end developers trying to take advantage of serverless. And finally, one of the things that one of my colleagues, Chris Anderson, said is that JavaScript has such a large use base, it's almost like the English of languages, which I think is very true. JavaScript remains one of the most liked languages across developers. But not only that, Node.js has small packages, which means that it reduces the cold start. So the smaller your packages, your dependencies are, whenever we're kickstarting our code, we're deploying the code and installing dependencies, if they're smaller, they're going to take less to install. It's also very commonly used for scaling in a distributed and horizontal manner. So we don't scale by adding more resources to our application, but we scale by executing in parallel. And then many times when we're writing serverless code, well, sometimes we have to write that in the browser. And by just not having to compile, to have a compile step, it just makes coding much easier. Cool. Some of the serverless providers that you might be familiar with are Azure Functions, and that's going to be what we're going to look into today, because I work for Microsoft and I do like Azure Functions. And then we also have Lambda from Amazon, and Cloud Functions from Google, and WebTask from Auth0, as well as IBM OpenWhisk. And Azure Functions and IBM OpenWhisk, they're actually open source solutions. So if you have a huge number of servers back home, whatever, hardware, and you want to run your own serverless solution, you can go ahead and just fork or, I don't know, clone the Azure Functions runtime and just run that in your own environment. And I think that's great. It gives transparency. So what can we do with serverless? Well, our favorite function in the world is hello world. And how this looks like, it's basically a function that receives a context, at least a context object as a parameter. And the context object is basically the object that we use to communicate between, to communicate with the function runtime. So we can call things like context log, which is the equivalent of console log, and this will just print information. So do some very nice debugging there, haha. And then set the response on the context object. We can do that. This is, for example, for an HTTP response, we can set the body for that. And we can also call the done method. And what this does is it's basically saying we have finished executing the function. So if you call done, this means that you will reduce the amount of money that you're paying. You're telling to stop running your code. Awesome, but this is not very interesting, right? Another very interesting use case is timer, or as many of you might know, cron jobs. So this is just basically running the same task or the same code every week or on a daily basis, on a monthly basis. You can do that very easily with serverless. But this is not extremely interesting either. How about Slack? How many of you use Slack here? Great, a lot of you. So I guess you're very familiar with slash commands, and we can actually develop slash commands very easily. The idea is to have somewhere some code that responds to a post request that is being sent by Slack. And ta-da! That's an HTTP trigger, right? And what I did here is basically implemented a function that will call the noun API, the noun project API, which retrieves some icons for me. And I think this is a nice collaboration type of project where if you're working on projects together and you want to find some icons for within your team for your project, you basically search for Iconify, and it will give you a series of icons that you can share with your team. The code for that is just this. And I'm sorry you don't see everything there. There's one line there that's weird. But what we're doing here is basically parsing the body. This is very small. Does this help at all? Not really. So what we're doing is we're parsing the text that Slack sends to us, so that includes the text that we're adding to our slash command. And then we're initializing the noun project object with the noun API key, which we can get from the project itself. And then we're also sending the API secret, and we're calling get icons by term. And we're sending the text, and then we're limiting the number of icons we want to retrieve, and then we are just returning that as part of the context object on the response, and that's pretty much everything. That's less than 100 lines of code, and you can deploy this. If nobody is using it, you're not paying anything. If a lot of people are using it, then maybe, yeah, it's a successful project. What about web APIs? We can actually implement, because serverless reacts to HTTP triggers, we can implement CRUD operations using serverless. And you can imagine an application. This is something that John Papa has created, an application that lists some heroes, and here you can add a new hero, create, update a hero, list them, and delete them. And with serverless, we can basically just react to different events and different method types, and just do all of that. Instead of having like an Express API, we can just, I'm going to show you the code in a bit. John Papa and I also worked on a Pluralsight course, and it's available at AKMS PBP. Has just been released. I'm super happy about that. And I've also published the GitHub repository at PBP Serverless. Another good use case for serverless is data processing, and this is a project that my colleague Sarah has worked on, where basically she's taking the cities that a conference is in, and then converting that into, using the Google API, she's converting that data into longitude and latitude, and then passing that into the Three.js library so that it can display this nice globe. Okay, I'm going to share the slides with you, so then you will actually get the reference to her article describing how she did this with Vue as well. But how do I get started? So here's the part where I do the live coding. I hope the internet goes well. I do have some videos, some recordings in case the internet doesn't work. And I hope that you will be able to see this okay. I'm going to increase the size here. Okay, so the first thing, who here has seen the Azure portal before? There's quite a number of people here. Awesome. So the first thing that we need to do here is create a function app. And a function app is basically like a logical container for all our functions that do the same thing. And this is actually useful because whenever you want to delete all your functions, or maybe you want to apply global properties, you can do that easily on your function app.
So could you try zooming in a bit?
Yes.
Thank you very much.
Awesome. Is this better for everyone? Yeah? Cool. So when I'm creating a function app, I need to give it a unique name because that's going to be the URL to my function. And then I need to say who's going to pay for this. I also need to give it a resource group, which is, again, a way of grouping things together. And I already have one. And then consumption plan refers to this pay-as-you-go type of plan. And that's pretty much everything. So I'm creating a new function here. And it's going to be available for me to inspect, to configure. I've also pinned it to my dashboard, which means that I'm going to be able to access it shortly. And this is great, right? This is nice. Some of us are used to coding in the browser, but most of us like and prefer using an IDE, right? And I think this is one of the things that differentiates Azure from many other cloud providers. It has a very good integration with, wait for it, who can guess? Julie there can guess.
Visual Studio Code.
Woo! Fantastic, that's right. So we can go, while this is, okay, the deployment was successful. I'm happy to see this. And I'm going to quickly show you this dashboard where we can just see some of the overview of the function. You can stop, you can restart. We can also do things like configure deployment options, maybe configure cores or SSL. But we can also create new functions. So I can go ahead and get started creating a new function in the portal. And there's 3 scenarios. So these are the triggers that I mentioned earlier, or the events, where you can react to API requests to HTTP. You can create functions that are executed on a timer or as a recurrence, or you can do data processing. And you can also choose the language that you want to use. So in our case, it will be JavaScript. But there are other options as well. And then you can create custom functions, which are more scenarios like use a template for GitHub hook or whatever. But I'm going to quickly go and create this function with JavaScript and the web API. And hopefully the internet is friendly. But in the meantime, I can show you the VS Code integration, which I love much more. So the first thing that you need to do to work with serverless in VS Code is install this awesome extension that has been created by Matt Hernandez, and it's called Azure Functions. And Azure Functions will allow you to do a lot of awesome stuff, like create functions and publish them, but also debug them on your local. And then there's a few, it runs on both Mac and Linux and Windows. And there's a few requirements there. You need the Azure Functions CLI, but that's pretty much everything. So I already have the extension installed, so I'm going to go ahead and just create a new function app here. And I can do that easily by just selecting all this stuff. And what has been generated for me here is the VS Code configuration, which allows me, it's already the debugging configuration that I need. And then also things like the host.json, which is general configurations for functions, and then local.setting.json, which is a very important file. This is where you get to store your secrets. And the cool part is you have your secrets stored here. They're not going to be checked into GitHub. And then once you deploy your application in the cloud, you're going to have a similar file there. So you can set up those settings there too. And it's just magic. Cool. So now I can create a new function. And I'm going to create it in the same folder. And you can see here the equivalent of the event. So it's the HTTP trigger, blob trigger is just a file trigger, and then queue trigger whenever we're adding a message on a queue, and the timer trigger. I'm going to use a HTTP trigger, and I'm going to call it getData. And you can choose whether your function is accessible on an anonymous basis, which means that everyone has access, everyone who has the URL has access. Function means that you need a token to call that function. And then admin, I think you need to have admin rights. We're going to go with anonymous. And this is how the code looks like. So it's almost like the hello world function you've seen earlier. But there's just a new test here whether our request contains a name or not. But other than that, everything looks familiar. So I can already go ahead and debug this. I'm just going to go to the small debug icon here and click play. And this is part of the CLI as well. And if I go to my terminal, I can see that my function has been deployed to localhost.API getData. And then I can go to this app, and it will give me this please pass a name on the query, which was the error handling we were doing earlier. We need to pass a name. So then let's just add a debugging breakpoint here. And say name is Julie, because we're super happy to have Julie here. And the function has stopped. So we can debug here, we can inspect the request element, we can inspect the query object, and this is fantastic because you get the chance to work on your local machine and run your code just as you do in everyday situation. But one thing that I failed to show you earlier is one of the projects that I worked on, which is I'm looking for an apartment in London. Is anyone here not from London? Oh, wow. Cool. So it's very difficult to find an apartment in London. I've already been in London for almost a year, but because you always get a crappy apartment when you're just moving somewhere, now I'm looking for a new apartment. And there's a lot of websites that help you find apartments for rental. So there's one called zoopla.co.uk, which actually has an API which you can call. So I thought, since I'm a programmer, why subscribe to a website when I can actually create my own function that calls the API of Zoopla and sends me a reminder, an email on a daily basis with new apartments. And the goal is really to have that email and then get that data, add it in a machine learning model, and try to understand whether the price has increased or not. And if you're wondering if Zoopla already offers that, I can tell you that it does. But it's not implemented by me, so I much rather trust me than other people. Does that sound familiar? So then the code for this is, I'm going to save you the, I'm going to save you from, look at me and be very slow while I'm typing. So this is the code for calling the Zoopla API. Is this visible for everyone? Cool. So what we have here is a function that receives a context as a parameter, but also the HTTP request that has triggered this. And I'm saving the query parameters in the body object, which I'm then going to send to the Zoopla API request. So that's the URL of the Zoopla API, and then I also need to pass the API key as a query parameter, but also I want things like, I want it to be in a certain area, I want to have a maximum price, and I also want to have a minimum number of bedrooms. And the method that I'm going to send is get, and then I'm just calling request. I'm filtering, and once I'm getting the data, I'm filtering that because I don't want to live in a shared apartment. And I'm processing that so that I can display it in a very nice Angular application. So this this looks familiar to everyone here, I guess. Like everyone has made an API request to a third-party service. And we can definitely also debug this. One thing that we need to do, so I mentioned the API key, right? Where do we have to, and this is a variable, I don't want to commit this into GitHub. So where do I have to save this API key? Anyone? Sorry? Exactly. And where do we save the environment variables in this project?
Tiny file you started from the beginning, the local settings.
Exactly. So we're going to local settings, and then I'm just going to add this API key, and I already have it saved here. I'm going to share it with the world. So it's this thing. And okay, so I'm accessing my API key, but I'm also using some npm packages. And what I'm going to do is basically create a new package.json file and just copy this. And this is going to add the request and load dash packages, which I'm using in my function. I'm also going to make sure that I am running npm install. Okay. And while that's happening, so I've created my function. I created a function app. I created a function that calls the Zoopla API. I'm running that. I wasn't able to debug it because we looked actually only at the Hello World application, but I can go ahead and run this. And we can see maybe in our, one second. So we can see in Postman, have you used Postman before? Yeah, awesome. So this is just for running HTTP requests. So my function is deployed at localhost API get data, and this should work, hopefully. Well, maybe I have to restart. But my goal here is to show that our function is up and running, making requests to Zoopla API, and I can definitely test that on my local. So you can see that the function execution has started. I have logged how many apartments we have found, and then that the function is completed, and we can see the results here, all the Zoopla entries that we requested. So now the next thing that we want to do is, okay, we have this in our local, but actually we want to have our functions in the cloud, right? And we can do that easily with the Azure Functions extension by just clicking this small button, which is deploy to function app. And this will ask which folder do you want to deploy, and then which subscription you want to use, so who's paying for this. And then it's going to ask me which function app do you want to deploy to. And Simona Cotin rental is a function app that I've created earlier. I also created iJS simple. And it's going to ask me, well, you are now running in beta, and beta is actually the runtime that supports multi-platform, whereas the first one was only supporting Windows. So I'm going to update the remote to use the beta version. And then it will also tell me, you know what, this function app already exists. Are you sure you want to override the contents of the function app with whatever you have in your local? And I'm going to say yes. And what this will do is zip up all the code that I've written and together with the Node modules, and then push them to the cloud. And it's going to take a second. But while that's happening, I'm going to also show you the application that I built. It's not great. It doesn't look not nearly as nice as the Zoopla API, a Zoopla website. And this is the cold start that I mentioned earlier. So the map is already loaded. It only has a pin to London. But as you can see, I have no data showing up in my list. And that's because it takes a while for the function to be deployed. I haven't called it in a while, so that's why it just needs some time to retrieve the results. And while that's happening, I can go back to our VS Code, and we can see that our function has been deployed. So this means that now if I go to the Azure portal, I'll be able to see the code that I've written locally in the Azure portal. And I'm going to refresh here. And ta-da! The getData function is here. And here we'll be able to see the code. And then on this part, we can see the logs of the function running. And on this side, we can also see, we can run some tests. So this is it. Obviously, I mentioned that we need to set the API key. We've set it in our local, but we don't have it set it up in the cloud. So the way to do that is by just going to our function dashboard, and then there's this application settings, where you can see things like which is the version of Node that you're using, but also you can add custom keys. So this is the environment variables. And I'm going to add the Zoopla API. And I have very little time left. But, so we have the key, we have the function deployed. So in theory, if I go to my function now and I copy the URL, I call it, I should be able to get the same data that I got in my local. And one thing that I did after I finished this function, I mentioned that I also wanted to receive an email on a daily basis with the new list of results. So one way I did that, which was very simple, was using this thing called logic apps. And logic apps is basically a thing to define a workflow. And I was able to define a step that's recurrent, and then run the function code, and then add that body to a function that basically sends an email using a SendGrid, the SendGrid product. So let's test this function first. And I'm just going to copy the URL. So you've seen I can just go in the portal, get the URL, and then here I just retrieved the data. So our function is running now in the cloud, and I can go ahead and use this link in my Angular application, just add it in my service, and that I just have to change one line of code, and this will be connected to the function that's created in the cloud. And you can see I've already used the previous function. But I really want to show you the logic app that I've created. So this is the UK rental. And this is how logic apps are part of the serverless architectures that you can use. And there's a logic app designer where you can just choose to create a step. So this is a recurrent step, and it just runs in a 1-day interval, but then you can define whatever interval you want to use. And then when you click plus here, you can add an action. And I added Azure Functions action. And this will retrieve the list of functions that I have already created. So that could be the Azure, the rentals, UK rentals. Okay. And then from there, I add a new action which integrates my code with SendGrid, and it sends an email. It sends me an email with the new apartments. So let me see if I can just go ahead and run this. Does this make sense? Does it look familiar? Has anyone looked into Logic Apps before? No, it's dead easy. I spent like 5 minutes on this, and not even knowing a lot about it. Just okay. So what do I want? I want a recurrent task. What does my task have to do? Well, I wanted to execute this function. What does my function return? Well, it returns a list of properties. So what do I want to do with those properties? I want to include them in an email. How do I send that email? Well, there's a few options. One of the easiest ones is using SendGrid. And I just went ahead and applied for a key for SendGrid, and that was it. And then, yeah, I can run the trigger, and probably I'm going to have an email right now with a list of properties. It doesn't look great, but it's my thing. Okay, so I think I covered a lot of things here. I didn't need these recordings, so I'm just going to skip very quickly through them. Local debugging, how do you create a function? How do you take it to the cloud? Okay. Oh, one more thing. You're working in a team, right? And you want to be able to share your code. You don't want to overwrite everyone's code. With Azure Functions, you can do Git deployment, which means that you're connecting your Git repository to your function. And whenever you're checking in new code to your function, this is actually going to trigger a new deploy of your function, and you're going to have your function in the cloud. So I think this is a great workflow where you basically test your function in your local, and then you maybe deploy it, you publish it to the cloud to an environment that's very similar to your production, but that's still not your production. You just want to test your code. And then once you know that everything works great, then you push it to GitHub, and then GitHub actually deploys it to a branch that's more production-like. So I think that's great. I love that. Okay, how you set it up. I'm going to share these slides. This is a great resource where you can see a lot of serverless maybe applications, or like you can see examples of things that you can build with serverless. And the cool part is that all of them are on GitHub, and you can press this deploy button, and it will actually deploy a function for you in the cloud immediately as it is. So in conclusion, with serverless, we write event-driven code that auto-scales, and we only pay for the resources that we use. I think that's a great deal for us. If you're interested in learning more, so I have shared this. There's an awesome list for serverless where you can read a lot of stuff. You can try Azure Functions at aka.ms functions. You can also check out the PBP dash serverless repo, which shows you how to create a web API using Azure Functions. And then Sarah's article as well. I do have some Azure passes. If any of you wants some just to try, let me know after this talk. And then for those of you who are from London, I recommend you check out this conference. It's called Serverless Days. It will be on the 6th of July this year, and it's a one-day conference. It's £35. It's very community-oriented, so it wants to be very accessible for everyone who's interested in learning serverless. I'm super excited about it. I'm going to be there. There's also a call for papers running if anyone is interested. And I want to leave you with this thought, where we're saying that the thing that distinguishes the best, fastest, and most efficient engineering organizations is how little code they actually write. So it's almost like zero code means no code. Well, perfect code. Cool. Thank you very much.